Hello all, welcome to Shakti's AI Junction. In this video, we will look into how data storing is performed using Llama Index framework. In our past videos, we have seen data ingestion using Llama Index, and we will continue with the data storing today. There are two ways of storing the data. One is in memory, and another one is a vector DB. In memory basically means like you are storing the data as well as embeddings in your local folder. And vector DB, you're using a third party or external some vector DB where you can effectively store the data. I mean, both the text as well as embeddings. Almost all of the open source vectors, vector DB supports both the text as well as embeddings, except to Fires. Fire supports only, I think, embeddings, not text. Okay, and I have chosen Milvus Chroma Qdrent as an example for today's video. However, if you want to explore another, vector DBs like Fires, Elasticsearch, and Redis, and you can. There are lots of examples over there in Llama Index examples, which you can take a look into it. But for a simple RAG use case, these three things will be sufficient to build a RAG application. Okay, there are four terms which I wanted you guys to remember so that it will be easier during the code. Vector store, persist directory, storage context, and index. Vector store, it is a placeholder where we'll be storing the embeddings. Persist directory, it is a folder in your local machine where you will be storing both the data and your embeddings. Okay, and the storage context, it handles the stored data, meaning you have the data stored in your folder, storage folder or vector DB. We have to retrieve that data and we have to use it for further processing. Okay, this is handled by the storage context. It handles the data stored in your folder. Okay, and index. Effectively, if you want to search some questions and against your data, you have to use index, which will effectively search the data and retrieve the data stored in your vector store or persisted directory. Okay, so we will look into it. Okay, so I have the Python version 3.12 and I'm installing python.environment, the Llama index packages. Okay, as you all know, for the completions model, I am choosing OpenAI, and that OpenAI key I have configured in the .env file. Okay, in order to activate that, I need to load that key from the .env file. So for that only, I'm using .env package. Import load .env config file path equal to need OS import OS path join OS dot get current working directory and assign that with config folder, and under that I have env file. So it's like the current working directory where my file, this Jupyter notebook is running, happening with the config file, and that finally env file. Okay. Mm. Now I have I have captured four files in my data folder. So we will fetch the data, ingest the data using simple directory reader. So from llama index dot core. So this is ingestion concepts will be available in from llama index dot core into simple directory reader. Okay, and documents equal to simple directory reader of data equal to current working directory. Okay. Okay, I just don't need to give this. Okay, if you look at it, all the documents has been processed at the page level and it has been captured in the documents variable. Meaning, if you look at the parliament1.pdf, there are 5 pages to it. Okay, so each page will be considered as a document and it has been broken down. Similarly, the Parliament Part 2 PDF has a 6 pages, so each page has been considered as a one document. Similarly, all the 4 PDFs has been processed and captured in the as a document. Okay, now we will see. Now let's apply some transformations so that we can break it down into further chunks. Okay, to do that, we have to import settings package and what is that embeddings package. So here I'm choosing uh, Hugging Face BGE embeddings. Okay, I'm not going to use OpenAI embeddings because we already have a very good embedding model, which is a BGE. You can go to Hugging Face website and see it. Okay, so there is a group called the Beijing Academy of Artificial Intelligence, and they have a collection related to Hugging Face, I mean embeddings. So these are all the models which they release frequently, and I'm choosing this model. It's a large model, BGE large ZHB 1.5. Okay, so let's copy that. I'll copy it. Okay, so I have imported settings, sentence splitter, meaning I'm splitting that text for further processing and converting into chunks. Okay, and for the Hugging Face embeddings, I'm choosing this model which I have shown from the Hugging Face website. Okay, now let's run it. And the chunk size what I'm giving is 1000 and the overlap as 20. Okay, now let's create index for this data. In order to create index, I have to have vector store index from from llama index core package, and from documents equal to documents, and transformations is equal to settings dot text splitter, and I have to give the embed model, embed model, embed model. Okay. Let's print. Okay, now index has been created. Now the first step, right? The persistent, what I was showing you here, the persistent method. For this one, we have to use a persistent method. So index dot storage context dot persist dot persistent directory. In the current directory, I'm creating a folder called storage. Okay, let's hit it. If you look at it, a storage folder has been created. Okay, it wasn't created earlier. Okay, to show it again, I can delete it, delete, and run it. See, now storage has been created again. So if you look at the storage folder, you will have the vector store, meaning embeddings in a JSON file, and a document store for document. It has a complete list of that chunks, not just documents. Uh, it has a complete list of processed chunks and the relationship, everything, all the data, metadata, everything has been contained here. This document will not have any embeddings because embeddings are already present in vector store. And there are other two JSON files, graph store, meaning like there is another method of data ingestion, which is a graph method, which we didn't use. So it is empty. Okay. And then also we have index. So this is a reference to that text documents, meaning the text documents, and that text documents will have one unique ID and the embeddings will have unique ID, and it is a reference. So which ID is pointing to which ID. Okay, and close it. Okay, now you have successfully stored your data as well as embeddings in your local folder itself using the persist method. Okay. Now let's ask a question. Okay. Uh, index dot as query engine response equal to query engine dot query of I know a question when Germany invaded Poland. So this must be coming under either one of the World War One or World War Two, and we will see if it. One second. Okay, so this is one of the question in the document. Okay, where regarding that Germany invasion on Poland. So this must be captured either in World War One or World War Two, and there must be an year. Let's see. What is error? Please either set open a key environment variable. Okay. Okay, I have ran that dot environment. Okay, I didn't load dot environment of. Okay, so actually I have given only the path, but I didn't load it. So that was the issue, and it is true. It is fixed. Okay, so the response is like Germany invaded Poland on September 1, 1939. So this is correct. This is from World War II, I think. Uh, that is World War II. World War. It must be somewhere here. This is no, it must be World War One. See, Germany invasion of Poland on 19 September. Poland on September 1939. Sorry. So this has been correctly captured. Okay. Now what we will do is like every time we don't need to generate the embeddings. Okay. Whenever we are trying to run, we don't need to generate each and every time, and that is a time consuming as well as you know, it's a computing process. So once we generate the embeddings, we can store it and we can retrieve it later. That's the purpose of storing in our local folder. Okay. Since we have already stored our embeddings here, and we can use it for the next time whenever we are, visiting the next time. So generally, when you're building a GenAI app, okay, and if you have the same set of documents, you don't need to, generate the embeddings again and again. So generated one time because you have the same documents, generated one time and use it, retrieve it whenever you want, whenever the application is running. Okay. So here I have shown you like how to store that in the persistent direct, in your local folder, but how to retrieve it. So for that actually, so how to retrieve, and you need to build an index. Index is equal to load index from storage. Storage context equal to storage context. Okay. Okay, I haven't declared storage context yet. Okay. Hmm. Okay. I just need to give this one. So storage context, how are we going to handle our the data? So storage context equal to storage context of storage context of from defaults, and we just need to give a process directory storage. Okay. So next time, when you don't want to, generate the embeddings again, you can use this command to load the data. Meaning the embeddings has been already generated in the storage folder and you are retrieving it. Okay. So how to test it? Let me restart it. Okay. So restarted. Now if I executed this query engine, I will not get any response because I have restarted and there is no value for the index. Okay, now I install Python OpenAI API key and that documents followed by okay index. Okay, now I executed till this fifth cell. Sorry, sorry, this cell. This index, how to generate an index by applying the transformation is I'm not going to execute now because we have already generated here. So instead of executing these three, I'm just executing this one. So where I can retrieve it. Now I have built the index. Okay. Now if I execute this cell where I can input it here. Okay, German inverted Corona 1931. So this is based upon the data whatever we have stored, we didn't execute it. Okay, if you look at it, we didn't execute this transformation, meaning we didn't generate the index. Instead of this, we use the index whatever we had already storage. Okay, this is how we do it using the persistent method. Okay, now we have seen how to store the index using persistent directory and how to retrieve it and query. Okay, now we will see the same thing using the second method, which is using a open source vector database. Persist directory. Okay, now I will choose Milvus vector DB. Okay. So for this, actually, we have to import some of the packages which is related to Milvus vector and this one. Pip install. Okay, so I have to install llama index vector source Milvus. Now, write the code for from llama index. This will not come under core because this is not a this comes under integration, right? This is a something we are integrating to a some third party. So these packages will come under other than core. So vector stores dot. So you see we have Chroma Milvus open search quadrant. I'm going to Milvus vector store. Okay, we have to declare what is that vector store Milvus vector store, and you have to give some unique identifier so that we can store that in a DB. dot DB, and what else we can pass? And collection token collection name. Collection name is equal to something like I can give anything on my own. And collection name is something I just given like some. and dimension of our vector of our embedding matrix, and overweight equal to true. Which meaning when I'm using the same collection and the same URI again, whatever the data I had already stored will be overwritten. Okay. The next step is to build a storage context. Let me do it. Storage context is equal to storage context from, it will be from defaults and vector store equal to vector store, whatever we have configured. Okay, and the next step we have to build index equal to vector store from index, and here it will be from documents because we haven't transformed the documents yet. Documents equal to transformations equal to, I think it's the same thing. I can just copy it from my previous code. Okay, and embedding model. Okay, let's see. Let's open it. Now we are processing the documents, applying the transformation, and storing it in this Melvus vector DB. It is a DB file that will be created. If you can see it, Melvus vector DB. You cannot, see it from Visual Studio, but this DB file has both the text and the embeddings related to our processing. And now we have successfully created our embeddings. Now, if I want to ask the same question again, I'll just copy it again. Query engine. On top of that query, see, from that index, we can build a query engine. And top of the query engine, we can pass our question as a query in a query method when Germany invaded Poland. See, Germany invaded Poland on September 1, 1939. It is also giving the which document that has been referring to. If you look at it, see, source nodes, node with a store, embedding, everything. So I will look into this, detail in the next video, but we will see how vector stores has been configured here. Okay, this is one thing. Now, same case, like this is before, this is saving to the disk. Okay, I will add it. Milvus markdown, saving to the disk, which means like we have created the embeddings and we are storing to the Milvus vector underscore db. Okay, see the same thing here as well. Persistent directory, like I will add a markdown here, saving to the disk, and this one loading from the disk. Okay, one more one. I'll use it here. Saving to the disk and loading from the disk code. Similarly, this is vector Milvus vector db, and this is saving to the disk. Okay. Similarly, now we have to see how to load it from the disk. Meaning you don't need to generate each and every time, because in real time I'm mentioning it again, it is just a 4 document, so you can just create on the fly. But in the real time production, like you will have multiple documents, like more than thousands and thousands of PDF documents. So for those things, you cannot just create on the fly, and it is very time consuming. That's the reason, like we are generating one time and storing it to the disk, and we're loading it again. Okay, for the future purpose. And to load from the disk, I just copy. See, the only difference is like this is the vector store index, which will be loading from the document. When we are loading from the disk, we are using from vector store. Okay, meaning disk. Meaning we are initializing the vector store on the storage context, and the index is saying, okay, take the vectors that has been already generated from the vector store. Okay, and in the vector store, you have to remove this override. Okay, you remove this override and execute it. See, look at the difference. See, for generating the index for the first time, it is taking 10.8 seconds. Okay, and when we are just referring or loading that from already generated embeddings, it is just taking 1.5 seconds. Okay, because here we are generating the index from the based upon the documents. Document meaning this one. Okay, but here we are generating the we are loading the embeddings from the vector store, and vector store we have configured here, that is milvus.db and a collection name rag, milvus.db collection name rag. So I have removed that override equal to true, meaning override means like even though the milvus.db file exists, it will overwrite. It will try to generate the new embeddings. Since I have removed it, it will not overwrite. Rather than it will pick from whatever we have stored. Okay. Now if I try to run this, okay, then Germany. Okay, let me run it. Okay, overwrite equal to true. 1 second. Oh, it is an empty. That we will see it later. Okay, let me see. Okay, in this case, when I'm reloading from the disk for Nilvus DB, it is not able to give the correct response. Okay, so let's see if that is the same case for the next DB, which is our Chroma DB. Markdown Chroma DB. Okay, and for Chroma DB, we have to load a package related to Chroma. Okay, Chroma DB. Now for this Chroma DB, again we have to import Chroma DB. Okay. So from the Chroma DB and the package from the vector stores, I am downloading Chroma vector store, and I'm giving the persistent, the path as /Chroma DB. If you see, there is no such folder here that will be created when I run this, and I'm using a collection called as a rag. Okay, and I'm creating a vector store, storage context, and index. It is a step by step. Like you have to initialize the Chroma client. Okay, like initialize Chroma client, then define Chroma collections, then define a vector store with collections. Okay, then define storage context with vector store. It's kind of a step-by-step process. Okay, and if an index will be based upon the storage context. Okay, let's. If you look at it, it is running, but you can see a Chroma DB folder has been created. So if you look at, see, this is a vector file. This is the embeddings file which has been created, and this storing in the form of a bin file. See, every open source vectors, they have their own way of storing. Okay, ChromaDB stores in .bin folder, and this is Milvus is storing in the .db folder. Whereas our default persistent directory, it is storing in a JSON folder. JSON is very easy to interpret. Okay, now let's ask the same. Now let's ask a question on top of this index. When Germany invaded Poland, and it is Germany invaded Poland on September 1939. Okay, this is with respect to say loading, saving to the disk, saving the data to disk. Okay, what if I need to load from the disk? Let's see if that works here. Load the data from disk. Okay, I'm just copying the same thing. I just need to make some fewer modifications. Okay, instead of this one storage context, instead of the from documents, I can use same like whatever I have given for here, vector store. Okay, copy this. Okay, now the index will be loaded from the embedding file, which is present in this ChromaDB folder. Okay, let's see if that works. Let's see if yeah, it is working. So let's test it by restarting it again. I mean, we will test this ChromaDB stuff alone by restarting, or I don't need to restart, or simply I could have created another vector and all. Wait, I will create another folder. Sorry. Python. Okay, it is storing everything. API key. I don't need the documents, but I don't need these things as well. And what I need, it's just the ChromaDB store. Like import ChromaDB and that file which is related to, I mean the package related to this one we have to store. And Chroma. Okay. Now I will copy this code. Okay, I need storage context and vector. Storage context and vectors. I can do that. These are all core functionalities. So it will be storage context, vector store index. From the vector store settings. From llama index into settings. Also, we will define what is the embedding function as well. These two things. Sentence splitter. Mode pass. Okay. Okay. Now I have loaded the, I am using vector store, which means from vector store I'm loading the embedding file from this Chroma DB folder. Let's see if this works or not. Ideally, it should work. Let's see. Okay, now it is giving the response. Germany invaded Poland on September, but it didn't mention the year. Which will say this particular test.apynb, it is completely having the files. I mean, it is loading the files from this Chroma DB and it is running against our index. Okay, this is related to load the data from the disk. Poland in September. Yeah, this is working fine. Now, same thing we can also do with quadrant. Okay. For quadrant, I suggest to log into the quadrant website, and they are providing a cloud storage which is of quadrant cloud, that is for 4 GB, I think, which means, yeah, 4 GB size of cluster you will get it for free, so you can make use of it, meaning you are storing the data as well as embeddings in the quadrant cloud. Okay, you can make use of it. I'll just open it. This is one which I have created. It's very easy to use. You will get one endpoint and one API key. Usage examples, Python, and API. This is how you can hit the quadrant. It is free. I mean, for 4 GB, you can use it for free. So it will be much more faster and efficient. Quadrant has many features, like it would be good when compared with the other open source vector dairies. And code quadrant client. Okay, for this I need to install some of my packages. Okay. And for quadrant, I need to use vector stores. Open quadrant. Okay, load from the disk query engine. From quadrant db. Okay, and for this db or into. This is a way how we can connect with it. See, I have there is a key which you will get it from this quadrant website. There is an endpoint and there is an API key. This is locker. Similarly, you will have one API key. Okay, you need this endpoint and this API key in order to store your data into this quadrant cluster. Okay, so I have given that key in my .env file and I'm referring it here, quadrant underscore API key. So this quadrant underscore API key I have configured in this .env file from my config folder. Okay, that's the reason I was able to hit it. Now let's see with quadrant. It is the same. I mean, the code, everything's pretty similar to like whatever we have done for Chroma and Milvus. Okay, it is the same. Like I'm just initializing a vector storage context and building a index using the from documents. From documents is like based upon the source document, we are building an index. Now let's query here. It is taking some time because it has building. Okay, now see invaded on 1939. It's 1939, correct. Okay, this is working, and you can see the data, whatever you have, pushed here, right? That will be here. So you can look at it like how much RAM it is consuming, and the disk write, the whatever the embeddings, whatever you have created, it is just 1.77 MB. Okay, so this is very good. You can track real time, like request, how much request you have made, and metrics, all those stuffs. This is good, but this is, you can utilize it for 4 GB, meaning if you're using it for a POC purpose for the demonstration, or you're getting started with building Gen apps, you can make use of this quadrant cloud. Okay, and if you want to load it from the disk, it is pretty similar to like whatever we have done earlier. Load from the disk and quadrant. And if I copy and add it on September 1939. Yeah, this is good. If I want to test it, go to my test.ip1d file, and instead of chroma, quadrant, QDRANT, install quadrant, and instead of this chroma, instead of chroma, I have to call these stuffs quadrant store. Quadrant. Quadrant client is missing. Quadrant client is missing. So, okay, this quadrant client is missing. Index has been built. Poland. Perfect. See, in the test IP1B file, I have loaded that quadrant for the vector using the vector store method. Vector store method, it will fetch the embedding files, whatever we have configured here. I mean, in the quadrant cloud, and it will pull it, and it was able to give that correct answer. So actually, we have trained in this video, we have seen like both the ways, persistent method as well as open source vector DBs. I think of all, Milvus was not giving the exact answer, but ChromaDB and this quadrant was giving the correct answer. So I think we can, I think most probably we can get started with the Chroma quadrant for our use cases. And this is retrieval, like you have your index built, and on top of that you can ask our questions and get the responses. So I will put on one more video, and like what are the different ways we can ask the questions, like what all the inferences we can make out of the answers, like you get a response and what do we infer from it, and how do we ask different type of questions, how do we ask different type of prompts. Those things we will cover in our next video. Thank you all, and keep supporting. Bye.